Hello, Math 150. How's everyone doing today? We are looking at section 3.5, and our objective is to graph rational functions. I'm going to give you an outline that you're going to follow for every single one of these problems. As a matter of fact, I've also included a typed up set of notes for you guys that you can find in Blackboard. I'll also try to attach it here at the YouTube video as well. So without any further ado, here are the steps to graphing rational functions. Number one, you're going to find the domain. Number two, you're going to do the X-Intercepts. Now, in steps 1 and 2, it's going to be all about factoring. You should really just factor everything you can to start, numerator and denominator. That will make step 1 and 2 much easier. Step 3, find the Y-intercept. Just plug in 0 and see what you get out. Step 4, find the vertical asymptotes or holes. And we'll talk a little bit more about holes as we go through some of these problems. Basically, we're going to be looking at our domain in that situation, finding out what makes our function go to infinity or negative infinity. Step 5, we're going to talk about the end behavior, what's going to happen when the graph goes all the way to the left or all the way to the right. In step 6, we're going to go back to our old friend, the trichotomy number line, to try to figure out whether or not our function is above or below the axis. I'm going to be doing about 5 of these problems, one problem per video. I'll be trying to post about 4 or 5 videos over the next day or so. So keep checking back and you'll see some more examples in case you get stuck. So our very first one. We've got f of x equals 6 over x squared minus x minus 20. Again, my first thing I'm going to say to you guys is just go crazy and factor everything you can. So our numerator on this one's pretty straightforward. It's 6. If we factor that denominator, we're going to get x and x, and we're going to get minus 5 and positive 4. So now we're ready to go with this. So our domain in this case, so here we go. Step 1, find the domain. The domain is all about making sure the denominator is never 0. So let's find out where it equals 0. And in this case, it's going to be x equals 5 and x equals negative 4. So these are the domain of this problem. X can't equal 5, x can't equal negative 4. If you want to use some interval notation, that's great. It'll be from negative infinity to negative 4, from negative 4 to 5, and then from 5 to infinity. Okay, so there's the domain. Now, what I'm going to try to do as we do this is over here, I am going to attempt to write down what's happening at each step along the way as we try to make this graph. So for now, what we know is we know that basically negative 4 and positive 5 are going to play a role in this problem. Those are going to be places where the function does not exist, so the domain does not include those two values. So the next step is to find the x-intercepts, and the way we find the x-intercepts is we are going to set the function equal to 0. So that's always found by making f of x equals 0. In this case, that's setting a fraction equal to 0. So that's going to tell me that we need 6 over x minus 5 times x plus 4 to equal 0. A fraction can only equal 0 if the numerator equals 0. In this problem, the numerator is 6. No chance. 6 will never equal 0. That means there are no x-intercepts in this problem. So we're never going to hit the x-axis. Next up is the y-intercept. In order to find the y-intercept, we're going to set the function equal to 0. So what we're going to do is we're going to plug in 0 into the function. I misspoke there. So it's the y-intercept. We're going to plug 0 in, which means doing 6 over something squared minus something minus 20 and plugging in 0 everywhere. That gives us a negative 6/20, which is the same as negative 3/10. So when we go over here, we're going to make a mark down here at negative 3/10, and we know that our function goes through that point right there. Next up is going to be the vertical asymptotes. So the place the vertical asymptotes come from, they are always directly related to the domain. So every time we find the vertical asymptotes, we're going to go back up and we're going to check the domain. So in this case, the vertical asymptotes come back from the domain. We got x can't equal 5, we got x can't equal negative 4. These values are either holes or they are vertical asymptotes. The way you find out is you go back to the original function and you plug them in. Now, I know we're not going to get a real value out, but we still want to know what happens when we plug them in. So if I plug in 5, I'll get 5 minus 5 times 5 plus 4. I will actually get 6 over 0. Anytime the numerator is not 0 and you've got 0 on the bottom, you've got a vertical asymptote. So the bottom line is if the top does not equal 0 and the bottom does equal 0, that is a vertical asymptote. So we know that at x equals 5, we're going to have a vertical asymptote. So I'm going to go back up here And I'm going to put that dotted line because our function is headed towards infinity or negative infinity there. I'm going to do the exact same thing. I'm going to plug in -4 this time. So this time I'm going to get 6 over -4 minus 5. I'm going to get -4 plus 4. When we work that out, we are going to get 6 over 0. Again, that is a non-zero number over 0. That means we have a vertical asymptote, and that's at x equals -4. So I'm going to go back up, and I'm going to put that one in. Now, when will you not get a vertical asymptote? If you get 0 over 0. 0 over 0 usually results in a hole. We'll be looking at that in one of our future examples. And I'll make sure I label that on the title that says this is the example with the hole in it. So now, the next thing we want is we want our horizontal asymptote. So to find the horizontal asymptote, we ask what happens to the function as x goes to infinity? And what happens to the function as x goes to negative infinity? So our function on this one was 6 over x squared minus x minus 20. And that's what it was. I'm going to use it twice, once going to infinity and once going to negative infinity. So in this one, what happens is this is going to behave just like the significant terms. We talked about this in one of the earlier videos. It's not very easy to see. The significant terms in this case, we got a 6 on the top and an x squared on the bottom. So this is going to behave like 6 over x squared as x goes to infinity. Same thing for the negative infinity. It works the same way. This is a case where the degree of the denominator is greater than the degree of the numerator. That always results in 0. So that means y equals 0 is our horizontal asymptote up here, okay? And just to be clear, x equals 5 and x equals -4 were the equations of those vertical asymptotes. So going back up here, what that means is I am going to get an asymptote along the axis. So I'm just going to kind of highlight that so you can see it. The last step in this problem is to create a, let's move that down out of the way, to create a trichotomy number line. So the trichotomy number line is going to come out, and we're going to make that for our entire function. So here goes the trichotomy number line, and it's going to be for 6 over x minus 5, x plus 4. So again, to make a trichotomy number line, we need to know the zeros of that function. Well, we already found them. There are none, no zeros. So no zeros. That was in step X-Intercepts, from the X-Intercept step. Now, an extra step on here, we may not have seen this before, is we have to put the undefines on our trichotomy number line as well. Undefines. And that's going to come from the domain issues. So our domain issues were where the denominator equals 0. That was x equals 5 and x equals -4. So when I put those on our number line, -4 goes on, 5 goes on. Those are undefined values. Okay, they're not zeros, they're not positive, they're not negative. When you put those in, you're actually just going to get undefined. Just writing that -4 over a little neater so you can read it. So now we're going to test these values in x minus 5, x plus 4, all of that below the 6. When I use any number from this region over here, and I plug it into this expression, I get 6 divided by 2 negatives. That's going to end up being positive. Positive means our graph is above the x-axis. If we use any value in here, it's going to be 6. This is going to be a negative. This is going to be a positive. That's 1 negative overall. So that's going to mean our graph is below the axis. And then we use any value over here. This is 6. This will be positive, and this will be positive. 3 positives gets us a positive. So what that means is we are above the axis right here. Let me write this out. This region means above. In this region, it means below. In this region, it means above. So when we go back up here, all right, we know in this region we need to be above. In this region, we need to be below. And in this region, we need to be above again. Okay? So when I go to graph this, because of the asymptotes, there's really only 2 choices. It either goes like this and uses those asymptotes the way I'm showing you, or it does this on the bottom. Well, we know the graph has to be above. So our graph in this region has to look like this. Okay, that's what it's got to be. In the second region, there's a couple of different choices because it's got to start on this asymptote. It might turn back around and go down. It might start on this one and go back up like this. It could start up here, turn around, or it could start here and go down. But we know it stays below everywhere. So you're not going to see anything going up to infinity on this end. It's got to go down. So we know it's got to approach the asymptotes down here. It's got to go through our intercept right there. And then it's got to stay below. It's got to stay negative. So it's going to go like that. So that's the way the region in the middle is going to look. When we go to our last region, again, we're using our asymptotes. It's either going to be this shape or it's going to be this shape. It's got to make use of the asymptotes. We know it's above, so it's going to be this shape right here. Okay? And it's just going to go continue in that direction. So this is the idea behind graphing rational functions. Again, I strongly recommend you to go look at the notes that I've posted. Use those as your guide. These are the steps. I'm going to do 4 more examples like this. I'll post them all as individual videos. Be sure to come back and look at the other ones. They'll go kind of increasing difficulty. This was one of the more straightforward ones because the numerator was so just a constant value. So come back, take a look at the next ones, and good luck with everything. Let me know if you have any questions. Have a great day, everybody.